Hi guys, welcome to Algebra 2 Lessons with Miss B. Today we're going to be going over lesson 13.4, compound interest. Okay, so when we have a regular growth function, it looks like this. F of t equals a 1 plus r to the t power. Okay, so when we have an interest function, it's going to be v of t equals p times 1 plus r to the t power. Okay, so I'm going to do a different color for this. So we'll do a nice pink. So P equals the amount invested. Okay, and then you have V of T, which equals value of investment. Okay, value of investment. We have R equals the interest rate. And t equals time. Now for R, it's the interest rate, so it usually comes in a percentage. So usually you need to divide, so you'll divide percent by 100, okay? So you'll see what I mean when we get to this example. Okay, so this example is asking us to, so we'll keep our equation there. So it says, find when the value of this account equals $10,000. They tell us that we initially invested $3,500 in an account that earns 3% annual interest, okay? So I'm going to, over here on my left, I'm going to write out my value. So I have P equals 3,500. I have R equals 3%, or which equals 0.03. 0.03. For a second I confused myself. T equals X because we don't know what that means. Okay, so I have enough to solve for V of T. Okay, so we're gonna go here and we're gonna put our Y2, okay, because we have to use our graphing calculator to be able to find these answers. Okay, we're gonna find the intersection. So when the value equals $10,000, so $10,000 is our Y2, okay? So our Y2 is 10,000. And we're going to find our Y1. We're going to do this by using our equation above. So we're going to do P times 1 plus R to the T power, okay? So this gives us 3,500 times 1 plus 0.03 T. So this gives us 3,500 times 1.03 t. Okay, so y1 equals 3,500, 1.03 t. So what you're going to do is you're going to, because I can't put a video onto this note section, so I'm going to say you're going to plug y1 and y2 into calculator. Okay, so you're going to graph those two, and you're going to find intersect. Okay, and then your x value, so whatever is x value of intersect is your answer. Okay, so in this case, when I graphed it, when I plugged 3,500 times 1.03 to the t power into my calculator, this gave me a value of 35.5. Okay, so this means x equals 35.5 years. Okay, so this is how long it's going to take for this account to reach $10,000. Okay, so here we have another example where this person invested $200 at 6.25% annual interest. And they ask us to find when the value of this account is going to equal $5,000. Okay, so I have my P, which is 200, my R, which is 0.0625, and my T, which is still X. Okay, or you can leave it as T, whichever you want. It's just when I plug it into my calculator, it's going to be X. And my Y2 is 5,000. Okay, so whatever this is your Y2. So I'm going to find my y1. So y1 equals p times 1 plus r to the t power equals 200 times 1 plus 0.0625 raised to the t power. Okay, so this gives you 200, 1.0625 t. Okay, so that's what y1 is. So you're going to plug y1 and y2 into the graph, okay, and then you're going to find where it intersects. And that's going to give you a value of 53.09 years, or about 53 years. Okay, so you just round it. So it takes 53 years for this account of $200 at 6.25% annual interest to reach $5,000. Okay? If you are confused on how to graph these problems, please refer to my video, okay, on YouTube. I showed you how to graph these. If you still don't understand, please reach out to me through the Remind app, Google Voice, or email. Okay, so this is our final example for this section, and it says that this person invests $1,000 in an account that earns 5.5% annual interest, and they want us to find when the value has doubled. Okay, so this is our keyword. So value has doubled. So our initial value is 1,000. Okay, so I'm going to multiply it by 2, which gives me 2,000. So my y2 equals $2,000. Because they didn't tell me my y2, but I had my initial investment of $1,000, and they told me it doubled. So that's $2,000. Okay, my p-value is 1,000 because it's my initial investment. R is 5.5%, so that's 0.05, and t still equals x. Okay, so we're going to find y1. So y1 equals p1 plus r to the t power. P is 1,000. 1 plus 0.05. T is 1,000 times 1 plus 1.05 t. Okay, so when you plug y1 and y2 into your graphing calculator and find the intersecting point, that gives you 12.94, or about 12.9 years. Okay, so then we go to this section, and it says we're going to find the compound interest for more than once a year. Okay, so over here in purple I wrote you a thing. So when it says that it's compounded semi-annually, quarterly, monthly, or daily, you're going to use these values. Okay, so our equation is v of t equals p times 1 plus r over n to the nt power. Okay, so n equals number of times that interest is compounded in 1 year. Okay, per year. All right. R over n equals interest rate. Well, here, we're going to do that. We're just going to say R equals interest rate still. Annually. Okay. So, an NT is your interest compounded in years, okay? You don't really need to know what that means, but I will write it out for you anyway. So R over N equals interest rate per compounding period. And NT equals interest compounded in T years. Okay? So we're going to use this equation right here and the values that we just learned to complete these examples. So it says a person, so we'll keep this where we can see it, okay? So a person invests $1,200 in an account that earns 2% annual interest compounded quarterly. Find when the value equals $1,500. This is still our Y2 value, so I'm going to list that immediately. Equals $1,500. Okay, my P is 1,200 since that's what I initially began with. And my R is 0.02. Okay, and it says compounded quarterly. Okay, so that means n equals 4, because that's what I just learned, or I just saw up here in my box. Okay, so I'm going to plug this into my equation. So this is y1 equals p1, 1 plus r over n to the nt power. Okay, so this gives me 1200 times 1 plus 0.02 over 4 times 4t. Okay, so this gives you 1200, okay, times 1 plus 0.005 4t, which gives you 1200, 1.005 4t. So this is your y1 value. This is what you're going to be plugging into the y1 in your graph, okay? Your y2 is going to be 1500. So when you plug those into your graph, you hit graph and then you find the intersect, that's going to give you a value of about x equals 11.18, or about 11.2 years. Okay? So here we have another example. It says a person invests $600 at an annual interest rate of 6.25% compounded semi-annually. Find when the value equals $1,700. Okay, so my y2 is right here. y2 equals 1,700. Okay, my p equals 600. My r equals 0.0625. And my t is x. Okay, and since this is semi-annually, if I go back up here to my box, my semi-annual is 2. Okay, so my n is going to be 2. So I plug it into my equation. y1 equals p times 1 plus r over n, nt power. Okay, so that gives me 600 times 1 plus 0.0625 over 2, 2t. Okay, this gives me 600, 1 plus 0.03125. So this is 2t. So this is 600, 1.03125. 2t. So you're going to plug 600 times 1.03125 raised to the 2t power as your y1, and your y2 is going to be 1,700. You're going to hit graph. You're going to find the intersect. And when you find where they intersect, it's going to be about 16.92, or about 17 years, okay? All right. So now they want us to find the equations for when interest is compounded continually. Okay, so this is a completely different equation. We have v of t equals p, the base e, r t. Okay, so p is still our initial amount. E is our base, so it's the constant e. Okay, we have r, which is still our interest rate. And t still equals time. Okay, so we're going to use this equation to solve for these examples. It says we have a person who invests $5,000 in an account which earns 3.5% annual interest, and it's compounded continuously. Find when the value equals $12,000. Okay, so here's my y2 value, 12,000. Okay, my p is 5,000. My r equals 0.035. My t equals x. And so I'm going to plug in, so I get v of t equals p-e-r-t. So this is 5,000 e 0.035 t. Okay? So this is what you're going to be plugging into your calculator for y1. Okay, so you're going to do y1 equals 5,000 times the base e raised to 0.035 t. Okay, y2 is going to be 12,000. And when you graph them and you find where they intersect, the value is going to be about 25.01. So that's about 25 years. Okay, so we're going to do another example. This example states that a person initially invests $350, which has a 6% annual interest rate compounded continuously. They want us to find when the value of this account equals $1,800. All right, here's my Y2. So Y2 equals 1,800. My P is 350. My R is 0.06. T equals time. Or T is still equaling X, sorry. T is time. So I'm going to do Y1 equals PERT, which gives me 350 times E raised to 0.06 T. Okay, so this is going to be what you plug into your Y1 value. Your Y2 is going to be 1,800. When you graph this and find the intersection, you're going to get about, so X is 27.29, which is 27.3 years. Okay? So finally, they want us to use two new equations to find and compare effective annual interest rates, okay? So they give us the equation for annual interest rates. R equals 1 plus r over n to the n power minus 1. So that's our equation for annual interest. Our continuously compounded equation is r equals e to the r power minus 1. Okay, so we're going to use this equation, or these two equations, to work on this example. So they give us two accounts. We have account X with the nominal annual interest rate of 2.5%, which compounds quarterly. And then we have account Y, which has a nominal annual interest rate of 2.48% and compounds monthly. Okay, so I'm sure you're sitting here and you're like, Miss B, why is this important? We're going to have people who calculate this all for us. That is true. But for these problems, we need to be able to do this, okay? So for account X, this is compounded quarterly, okay? So we're going to use the equation, okay? R equals, so this is, I'll relabel this, is going to be account X, okay? So my N equals 4 because it's quarterly. My R equals 0.025, okay? Because this is my, so 0.025. Okay, so I'm going to use this and plug this into my equation. So R equals 1 plus R over N raised to the N power minus 1. So I'm just going to plug this in. So I'm going to get 1 plus 0.025 over 4 raised to the 4th power minus 1. Okay, so this gives me 0.02508, or sorry, I am looking at the wrong problem. Okay, so this gives me 0.02523. Okay, in order to get a percentage, I multiply by 100, which gives me 2.523%. Okay, for account Y, okay, looks a little bit too much like X. I'm going to do the same thing. So my N equals 12 because this is monthly. Okay, so N equals 12. All right. R equals 0.0248. So I'm going to plug in. So I get R equals 1 plus R over N raised to the N power minus 1 gives me 1 plus 0.0248 over 12 raised to the 12th power minus 1, which gives me a value of 0.02508 times 100 gives me 2.508%. Okay, when I compare 2.523 by 2.508, okay, the account X is a higher value, okay? So you're going to choose account X, okay? Because 2.523 is bigger than 2.508. All right. So here we go. We're going to go to account A, which is a 3.24% interest rate compounded continuously, okay? And account B, which is 3.25% rate compounded semi-annually. And they want us to find which account, should we choose. So I'm going to do account A. Okay, so this is compounded continuously, so I'm going to go back up here because I want to make sure that I use the correct equation. Okay, so for annual interest, we have the one equation, but for continuously compounded rates, we're going to do R equals e to the R power minus 1. Okay, so this is R equals e minus 1. Okay, so I'm going to find that my R equals 3.24, is 0.0324. Okay, so I'm going to get e raised to 0.0324 minus 1, which gives me a value of 1.0329 minus 1, which is 0.03293, and then that gives you 3.293%. Account B. Okay, this is semi-annually, so I'm going to use my other equation. R equals 1 plus R over n raised to the n power minus 1. This is 1 plus my interest rate so R equals 0.0325. 0.0325 divided by n, so my n is semi-annually. Okay, so this is n equals 2. Divided by 2, raised times squared minus 1. Okay, so this gives me 0.03276. And when I multiply that by 100, that is 3.276%. Okay, so in this case, 3.293 is bigger than 3.276. Okay, so we're going to choose account A. Okay, so I know that's a lot of information, you guys, so if you have any questions or you need more examples, please feel free to reach out to me, okay? I know that I just did a bunch of numbers right here and I didn't show you the graphing, but my video of graphing the equations will show you how to do this, all right? So if you need to pause this video at any point and go watch that, you can do so. I look forward to talking to you guys soon.